The Regenerative Way begins where the pavement ends. I'm Ryan Snosky, bringing forward conversations with researchers, conservationists, educators, guides, and knowledge keepers from around the world to help us reconnect with the land. These are stories born in the field, raw, unpolished, and shaped by the landscapes that hold them. Together we explore what it means to come back into relationship with land, with food, with wild places that shape who we are. Steph, thank you so much for bringing me back to one of your favorite places. I absolutely love this view, and it's so different than the last time we were here. Do you want to just speak to where are we right now?
Sure. So behind us here is the Kwäch'än River. The Kwäch'än is one of the major tributaries of the Yukon River. It joins the Yukon River just a few hundred meters downstream here, just downstream of Whitehorse. So we're not far from Whitehorse. And upstream, it flows 150K or so to Kusawal Lake.
Okay.
Yeah.
Whereabouts is that? That's still in the Yukon?
It's still in the Yukon, yeah.
Okay.
Yeah, it's not far.
Yeah.
There's a beautiful, two actually, territorial campgrounds there. So it's one of the places you'll have to check out in the Yukon.
Yeah. 100%. And why is it so special to you, this view?
Well, this is a place that's close to my home, so I come here often, and there's a running trail that goes just over there and along a ridge. So it's a loop I do a lot, and this particular viewpoint is a bit off that loop, but I always take time to kind of do this little side trip, just 20 meters to come and look at this view, take a breath, and realize what a beautiful place we live in.
Oh, I can imagine. Yeah. I love the idea of like a sit spot.
Yeah.
Both times that I've been here, just that idea of being here and being present.
And it changes all the time. Like I usually try and snap a picture because depending on the weather and the season, even though it's the same thing you're looking at, it can be totally different. And so we're lucky today. It's cleared up a bit and we can see across to the mountains, which is beautiful. But just imagine those mountains with like fall colors, and the river flowing kind of blue-green. It's beautiful. Yeah,
I can definitely imagine that. Yeah. Only got to experience one fall up here so far, but it's so stunningly beautiful. Yeah. Amazing. Do you want to just speak to some of the work that you're involved in, some of the passion, even connection to the Kwäch'än River and the Yukon River? How is it all interconnected?
Well, for me, I work on salmon a lot of the time now. That's my focus. So the Kwäch'än River is a major spawning tributary for Chinook salmon. They come up here. And salmon migrate almost 3,000 kilometers to get here from the mouth of the Yukon. It's quite incredible. And so I think that journey just reminds us that all of these waterways are connected, like fish swim all the way up here from the ocean, through Alaska, across the border, through dozens of traditional territories of different nations to get here. And so it's, their journey, I think, is a reminder of how connected all these places are by the rivers.
Yeah, it's hard to comprehend when you say 3,000 kilometers.
I know.
And,
yeah, they're quite unique that way. Like most salmon, there's very few populations that migrate that far. So they're pretty special that way. And we don't get chum salmon here, but they go almost just as far up towards Teslin, which is very unusual for chum salmon. They're usually in like the lower reaches of the river. So the Yukon definitely has something special with these salmon populations.
Why is it that chum salmon travel that far or don't normally?
That is a great question. I don't have the answer. Just typically their life history. They do not spend any time rearing in freshwater. They migrate to sea right away as juveniles. So I think that sometimes limits kind of how far upstream they go. And it's also just, every salmon species is adapted to different habitats, utilize different spawning reaches of the river. And so chum salmon tend to usually be a bit lower down. Except in the Yukon. They come all the way up here.
Yeah. Because I heard that king salmon are the Yukon River. It's the longest migration in the world, isn't it, for salmon?
I had to look into that because someone actually wrote that the other day in a report I was editing. So I looked into it. I think they're one of the longest migrations anyway. So yeah, king Chinook salmon, same thing. I think there might be some pretty far-reaching populations in other places, but it's definitely one of the longest. Yeah.
Yeah. It's truly remarkable. Like
Yeah.
just thinking about the complexity of that ecosystem and going from the ocean all the way up to a lake that's 3,000 kilometers away and then redoing that journey.
Exactly, doing it twice. Like we
Yeah.
often think about the spawners, right? Like they're the iconic fish doing their last push to their spawning grounds before they die, but they do it as juveniles too, going down, which is just as remarkable. So, yeah.
It's truly remarkable. Before we get too deep into salmon, because I definitely would love to pick your brain and learn so much more about salmon, where does your passion for salmon originate? Like, have you always felt that connection?
I don't think so. I mean, I grew up in the interior of BC, so I didn't grow up going salmon fishing every summer or seeing salmon return to my backyard. Although there are kokanee salmon that spawn in Kootenay Lake in the West Kootenays of BC, where I grew up. So I did grow up seeing the little tiny kokanee salmon with their red colors coming back every fall to Kokanee Creek. But I didn't have a big connection to salmon growing up. It wasn't until the second year of my undergrad at the University of Victoria that I had the remarkable good fortune of getting a summer research position with a PhD student who was working on studying the impacts of parasites on salmon in an area called the Broughton Archipelago on the near the northeast tip of Vancouver Island. And so I was kind of thrust into the world of salmon research with that summer job. And it really kind of changed the course of my career. It was really formative for me.
Yeah, I can imagine that would be extremely formative. If you can just fill in the gaps at like a high level, from my understanding, is the Broughton Archipelago is so significant because you have the Queen Charlotte Strait, that all the mammals migrating from Alaska down through that corridor, bringing in abundance of salmon, bringing in abundance of life. So I can imagine just how much of a David Attenborough-like experience you had immersed yourself in.
Yeah, I remember actually one day during that first summer I was there going to the outer islands. So yeah, I guess just to back up. So you have Vancouver Island, there's the Queen Charlotte Strait, and then it turns into Johnston Strait, and there's several kind of archipelagos of islands. Across the strait on the mainland, the Broughton Archipelago sits kind of nestled in those mainland inlets, like fjord type ecosystems. So it's pretty remote because it's boat access only. You can't drive there. There's no roads except for some logging roads. And so that immediately, crossing the strait, you immediately feel like you're stepping away from society a bit into this wild place. And I remember one day, in the outer islands on a rare afternoon off, I think doing field work, just witnessing, these humpback whales coming, sea lions everywhere, fish jumping everywhere, gulls going crazy. Like the abundance of life there was just incredible.
Yeah. Had you ever experienced something like that? It was the first place in my journey that I got
remember
to
you saying you've been
experience
there.
it.
Yeah.
Like up into that point, had you ever been in a place that was just so vibrant and teeming with life?
Not in the same visible way. Again, I grew up in the interior. I spent a lot of time outside in the mountains hiking with my family growing up. And so I saw a lot of wildlife, but often in the forest, I think things are hidden as they are in the ocean. But you have these sometimes just events, whether it's a herring spawn or some other school of fish, and just the feeding frenzy that happens when that, and all of a sudden all this life that's hidden beneath the surface is right there kind of going for it. And so it was pretty cool. And as a young researcher, it was quite inspiring to be kind of exposed to the world of, seeing things like this, whether it's a predation event or, some interesting behavior, and suddenly being exposed to the idea that, why do they do that? What's going on here? Well, we can find out. We can do these little experiments, or we can do these observational studies and figure out why they're doing that. Yeah. And so I found that was really my hook into research, was being in this amazing place where there were so many things going on, and then being with a group of people who were constantly, thinking about why things were happening or what were the implications of that, or how would this affect survival or conservation of these species. So it was just, like I said, a very formative research experience. And then, of course, there was the group of people who were mostly looking at the impacts of aquaculture on wild salmon. So there was a really like conservation ethos and motivation there that was quite inspiring.
Yeah. There's kind of two, and so I guess choose which direction you want to go. I hear so much of what you're saying, and it really speaks to land-based experience and just how transformative it can be for research and, you know, the concepts that you're applying in real time and learning from the other individuals that are part of this experience. And I imagine you had, you know, ample time around the fire and potentially out on the water fishing or crabbing or these sorts of things.
Yeah.
But then there's the other side of I really want to get into like the research particulars on like what were you doing around sea lice and
Yeah, maybe I'll start with the latter because it's a little bit easier, more concrete. So I was working with a PhD student at the time who was trying to understand the impacts of sea lice parasites, which are like small lice, like ectoparasites we call them, that live on skin, and they can be transmitted from farm salmon to wild salmon. And there were lots of concerns that these sea lice were being amplified in the farm environment by all these farm salmon and then spilling over to infect juvenile wild salmon as they migrate past the farms. And then that was having impacts on survival of wild salmon. And so the concern was, you know, you have these aquaculture facilities that are kind of popping up all over the coast, and there may be unintended consequences on wild salmon, which is sort of the opposite effect to what they were supposed to have, which was like aquaculture was supposed to relieve pressure on wild salmon, right?
Yeah.
And create a food source. So it was an interesting area of research. We were specifically looking at, so we'd catch juvenile salmon along their migration and then count the number of parasites on them to try and understand if we saw sort of a rise in parasites as they pass by farms, and can we try and attribute that to a point source at a salmon farm.
Okay.
So it was lots of boating around, setting beach nets, looking at juvenile salmon. And I often joke actually that I'm a salmon biologist, but like I don't know anything about the big salmon. I couldn't tell you what's like embarrassingly. You know, people present me with a salmon they just caught and they're like, oh, what species is it? Or where's it? I'm like, can you show it to me when it's 3 months old and I can tell you? I spend a lot of time looking at juvenile salmon. So that was the core of our work, was doing that kind of sampling.
Okay.
And then I had the opportunity to do some little side project as an undergrad research student. And so there were a lot of other questions that came up as we watched these juvenile fish with sea lice. And just as an example, you know, we'd pull in the seine net. So a beach seine net is like a long panel of net essentially. And you set one end on shore and then you drag the other end around with a boat and drop another person off on shore with the other end, and they pull it in on shore.
Okay.
So you get this little kind of purse of fish in your net. And sometimes when we do that, we'd not only get the juvenile pink and chum that we were targeting, but we'd get some yearling coho in there. And the yearling coho would just start to go crazy feeding on the pink and chum, which are, you know, you're younger and quite a bit smaller. And it was really interesting to watch this because you could see how, you know, these predation events were really important in shaping survival of juvenile salmon. And, you know, you could see that fish that were heavily infected with sea lice, you know, they don't swim very well. They don't do very well. And so we started to think about, well, does it affect their ability to evade predators in these environments? And so one of the projects that I got to do was looking at how sea lice affect the swimming behavior of juvenile salmon.
Okay.
Which, you know, if the salmon are affected, they can't swim as well. They might not be able to evade predators as well. That might kind of compound the impact of lice on them. So not only are they dying because they're infected and, you know, having their blood sucked, but they're dying because they're less able to avoid predators. They're less able to compete for food. Like there's all these kind of ecological effects of parasites that we started to look into. So I did a little experiment with a budget of about $50, taking a kiddie swimming pool and putting a bilge pump in the middle that induced like a current that the fish swam against. And then we could look at, okay, how do infected fish position themselves in the school? Do they lag behind? Are they on the outside and potentially more susceptible to predation? So it was really fun. It was a really fun little experiment, and for me, it just opened my eyes to, like you have these questions, and you can go and figure that out.
Yeah.
Like it's really fun, creative process.
Yeah, it sounds like a really fun, creative process. What were the findings? What was the impact of sea
Yeah,
lice?
so that was actually that was published eventually as part of a broader study that looked at how sea lice affect not just schooling ability, but ability to evade predators or competitive foraging, all sorts of things. And we found that infected fish were more likely to be on the periphery of the school and at the back. But there was a lot of variability between species and depending on the size of the louse and the size of the fish.
Okay.
So one of the challenges of doing these kind of semi-natural experiments in the wild, like we weren't in a lab, we were catching these fish in the wild and using, naturally infected fish. We weren't infecting them ourselves in the lab. And so as the season progresses, your fish get bigger and the impact of the lice becomes less pronounced because the fish are bigger. And so they're more robust and can kind of withstand the infection.
Yeah.
And so, you're struggling to get a big enough sample size to have some conclusions come out of your study. And at the same time, the fish are growing bigger and bigger and reducing your effect size. And so it was sort of a race against time to see what we could find. And we ended up not having highly significant results for all species in all trials. But overall, we did see an effect on the schooling behavior.
Is there an effect on the salmon that eat infected salmon?
That's a really interesting one. Yeah, so one of the people who was out there was looking at this, how sea lice can actually jump from their prey to their predator during a predation event.
Okay.
Because they're ectoparasites. The adult sea lice are mobile on the fish. They can move around. And so what he found is that during a predation event, the lice will actually jump off and end up on the predator. And so predators like coho salmon might be getting a double dose of lice because they themselves are becoming infected from lice in the water column, but they're also potentially getting the lice from their prey.
Yeah.
So it's quite interesting.
Quite interesting. So naturally, is there natural infection happening already?
Yeah. Sea lice are a naturally occurring parasite in the Pacific. So the thing about Pacific salmon, though, is sea lice can't withstand freshwater. They die.
Okay.
And wild salmon also die after spawning. And so in a natural life cycle of salmon, the adults will come back, they'll spawn, and then they'll die. And when the juveniles hatch, there aren't really adult salmon around with parasites to transmit to them. And so juvenile pink and chum in particular migrate to the ocean right away. And so they're quite small when they enter the marine environment, but there aren't a lot of salmonids around to transmit lice to them.
Okay.
At least initially. Whereas when you introduce salmon farms, they're often in these inlets very close to the river mouths where the juvenile salmon are migrating out of. And so they act as a reservoir of adult parasites and other diseases. Sea lice are just one example of a pathogen that can come from a salmon farm. And so the salmon farms act as a reservoir that can then transmit parasites and pathogens to juvenile salmon very early in their life cycle when they're kind of more vulnerable to the impacts of these diseases.
Okay.
Does that make sense?
Yeah, it definitely does. Yeah.
So it's not that in some cases they're introducing novel pathogens, but in the case of sea lice, it's more like they're amplifying and disrupting a natural separation of adults and juveniles.
Yeah.
And that's the problem.
And it's too bad because in some ways, even in my own kind of framing of aquaculture and fish farming, you would like the idea that there would be a way to do it without having this broader impact, but the way that you're laying it out, it seems like it's so detrimental. And you were saying BC is no longer doing fish farms, if I'm correct?
There was a recent court ruling to uphold the decision to phase out salmon farms from the West Coast, at least open net salmon farms. So, you were saying there should be a way to do it, and there is. It's closed containment. Okay. Which is like, moving salmon farms onto land or in containers where parasites and pathogens can't, they're not sharing water with wild fish. And so there's not that potential for transmission.
I see. Okay. Yeah. Okay. So there is a way to do it, but we just need to reimagine it and not.
It's just more expensive.
Yeah. Okay.
Yeah.
Okay. So you were 22 and you conducted this study.
I was actually only 19 when I went out there.
What?
Yeah. Yeah.
Where did I get 22?
I don't know. Second year university, maybe.
Second year university. I was 22.
Yeah, it's crazy. Like I was still a teenager, but yeah, that's why it was like this critical point in my life, right? Where I was like, okay, I'm not a kid anymore. I'm not going to work at a summer camp. What am I doing with my life? What direction do I want to go? And research was there. It was, a really, really awesome experience.
Yeah. Just 2 seconds.
Yeah.
Just gonna make sure this is pointing in the right direction. I was gonna get a little bit more comfy. 19 in the Broughton Archipelago.
Mm-hmm.
Okay. And how many years were you then in the Broughtons?
Yeah, I ended up, so I did a couple of other work terms and had some other experiences during my undergrad, but I did go back there over a period of 10 or so years to help out with field work, and then eventually I did my own PhD research there, working on juvenile salmon and sea lice. So it was a period of about 10 years that I went back there every year.
That's incredible.
Yeah.
So it's become a place for you.
Yeah.
A very, very special place.
Yeah, for sure.
Do you want to walk me through like what it was the PhD research that you were doing there?
Yeah. So I finished my undergrad, and it's funny because that experience in the Broughton was my first work term ever. And then when I was graduating, I was like, okay, what do I want to do? I want to go back to that. Like that, I had kept that up kind of on the side, and it drew me back. And so I had the good fortune of being able to start in a grad school program with the same supervisor that had supervised that PhD student I worked with years previous.
Amazing.
And the PhD student himself, actually. So I started a program kind of following up on some of that original research, looking at parasite loads through space and through time as salmon migrate. And then also digging into the predation thing a little bit more, like how, what effect does predation have on juvenile salmon survival with and without sea lice? How does that unfold?
Yeah.
So that was most of my PhD research, which took me 5 years, I guess. I graduated in 2015.
Okay. Mm-hmm. Do you want to, when I think about salmon, like it seems so complex, it seems so abstract and big. There's so many influences that are part of that system. Like how did you navigate studying something as simple as, parasites within juvenile salmon?
Well, that's one of the main challenges, is that they do have such a complex life cycle, and there's so many threats and stressors throughout that. How do you pinpoint what impact do sea lice have on juveniles?
Yeah.
On the populations as a whole, right? Like even if some proportion of the population die from sea lice as juveniles, a lot of juvenile salmon die anyway. And so maybe that mortality is just what we call compensatory. Maybe the ones with sea lice died, but some proportion would have died anyway, so the sea lice didn't really matter.
Okay.
And so that's a lot of what I do now, and kind of did over that period, was trying to look at the population data. So actually, the survival of salmon over their life cycle, and the numbers that come back to rivers, and try and determine if we can quantify the impact of different stressors, including aquaculture, on survival.
Okay.
And I think it's sort of like being a bit of an ecological detective, because many of the stressors throughout the life cycle we don't have data on, and we don't know exactly what's going on. And so we have to use the information we do have to piece things together and try and figure out, okay, what is the likelihood that this aquaculture facility is having an impact? Or is it all sea surface temperature and, other things? So it's a bit of detective work. And how are you navigating that detective work? Like when you think about a system in the Broughtons, like how big of a geographical area are you trying to bring in that system? Mm-hmm. Yeah, well, that's an interesting point. It's always more powerful if you can look at broad scales, right, and do some comparisons. And so one of the things that we did in those studies was do what's called kind of a before-after control impact type design.
Okay.
And so we tried to get data from before aquaculture was introduced into the Broughton. We tried to get data from after aquaculture was introduced, as well as control areas. So other regions along the coast where there isn't aquaculture, and there wasn't during that whole period. because that allows you to try and control for kind of temporal changes that might be due to broader factors like ocean conditions that affected all populations, and try and get at that kind of impact of interest.
Yeah.
So ideally you're bringing in kind of broad scale data, but of course that also brings in complexity of other stressors that might be happening in other regions.
Yeah.
So.
What, really difficult question, but what are some of those main stressors that are just affecting Pacific salmon as a whole?
Well, climate change is a big one. I'd say
Okay.
that's kind of an overarching theme because climate change is affecting so many different aspects of salmon's life that you can, freshwater, marine, things like flow and stream temperature in the freshwater environment, and then everything from food availability to ocean currents, sea
Okay.
surface temperature, salinity, all sorts of conditions in the marine environment. So it's a major stressor that's changing the environment salmon encounter throughout their life cycle.
Yeah, yeah.
In different ways. But there's other kind of broad factors that operate on kind of ocean basin scales. And one of the big ones that there's increasing evidence for is competition, in particular competition with hatchery-produced salmon.
Okay.
So there's a huge production of pink salmon in particular that happens. Countries like Japan, Russia, and the US produce hatchery pink salmon that then rear in the ocean and compete for resources with wild salmon. And you can actually detect an impact of
Interesting.
that hatchery abundance on survival of wild salmon.
Yeah.
And it's not just, salmon in the Broughton, but salmon in the Yukon River. This has been a quantified effect
Okay.
on them as well. So
Because we're putting in the artificial input of like exacerbating this population.
yeah, exactly. There's actually more salmon in the North Pacific than there's ever been before.
What?
Yeah.
Okay, I didn't know that.
Yeah, they're just not wild salmon that are coming back to BC and Canada.
Okay, I had no idea. So you said it's Russia, the United States. Is Canada doing similar things?
Canada does some hatchery production, but not at the same scales as,
Okay.
as those other countries, yeah.
And why is it pink in particular that they're...
Pink salmon, they're pretty easy to produce. They're pretty quick to reproduce, so they have the shortest life cycle of any salmon. They live for 2 years exactly, and so it's a pretty surefire way to have fish come back in 2 years.
Yeah.
And I think that they're pretty desirable from a food perspective. Yeah.
Do you see any benefit? I know during some of our conversations you've talked about that idea of resiliency and that idea of population resiliency. Is there any benefit to bringing in this artificial population, or do you think it's deteriorating some of that?
You're opening up a can of worms here. Yeah, I mean, hatcheries are such a lightning rod issue because there's very different types of hatcheries for salmon,
Okay.
right? So what I was talking about with the pink salmon, that's like a production hatchery. The goal is to pump out as many salmon as possible and have as many come back. On the other end of the spectrum, you have conservation hatcheries, which are focused on avoiding populations going extinct.
Yeah.
So these are used in cases where the populations have got to such low numbers that there's concern that we're losing critical genetic diversity within that, like fewer than 1,000 individuals sort of thing.
Okay.
And then they might bring in a conservation hatchery just to try and ensure that this population doesn't become extirpated and we don't lose them altogether.
Yeah.
And that conservation hatchery would have very clear goals and a clear endpoint, right? It's not something that's going to be there in perpetuity. The goal is just to make sure this population can recover.
I see.
And then you've got everything in between,
Yeah.
community hatcheries, hatcheries to help bolster populations for commercial fisheries. There's a whole spectrum.
Okay.
Yeah, and certainly, like there's been several recent papers that have reviewed the literature, and the consensus seems to be that almost everywhere hatcheries have negative impacts on wild salmon, with the exception of a few conservation-focused hatcheries.
Yeah.
Yeah, so it's very controversial, especially because a lot of salmon stewards and community hatcheries, they do good work, right? But we have to face the reality that there are negative impacts of hatcheries because because they compete with wild salmon, they can dilute important genetic diversity and adaptations that wild salmon have. They can transfer diseases unintentionally to wild salmon. So there's all sorts of unintended consequences of hatchery.
I think it just speaks to the complexity that I had no idea that it would be, you know.
And the nuance, right?
Yeah.
Like it's not hatcheries are good or hatcheries are bad. It's like, how are you doing it? What are your goals? You know, and the same could be said for aquaculture, really, right? Like, yeah, you can have closed containment that does all the things that aquaculture was lauded for doing.
Yeah.
Or you can have open net salmon farms that are poorly managed and are really a net detriment to wild ecosystems. So,
Yeah.
yeah.
It's hard to comprehend how many influences and pieces are tied into this story, and how you have, resource extraction, logging, hatcheries, fisheries. There's so many moving pieces.
Mm-hmm.
I guess one thing that I was really hoping to explore is just when people think about salmon, I don't think a lot of people understand how unique of a life cycle it is, and how it encapsulates all these different, political spheres, all these different aspects of the river, all these different, sources of impact. Can you just try and walk through like the life cycle, I guess, of salmon?
Sure. Yeah, and the Yukon is a perfect place to think about that, because the Yukon River is one of those transboundary rivers, right, that flows from Canada into the U.S. And so that adds a layer of complexity to the salmon story as well. But yeah, I mean, as juveniles here in the Yukon, these eggs hatch and it's still winter effectively. Like, it's extremely cold. They have extremely low levels of food.
Yeah.
And juvenile Chinook rear for a year in freshwater before they migrate to sea in the Yukon. There's different life history types for Chinook, but the ones here they're stream type, they tend to rear in freshwater for a year. And so they're spending a winter, under the ice here, often in very small, shallow places that are very cold and unproductive, trying to grow before they get to the ocean. And then they have to migrate downstream past all the predators and other stressors that they have along the way to the open ocean. And juvenile Chinook from the Yukon spend time in the Bering Sea, so they'll spend time there. And the food quality is a real stressor at that stage. Like, they're trying to get enough food to grow big, and that first year at sea is a really critical period for Chinook, where it kind of determines, for any salmon really, are they going to grow fast enough and be big enough, to avoid predators and make it, or not. So
and what are they eating? Sorry.
They're eating small kind of forage fish and zooplankton, and different species have different diets.
Okay.
Yeah, all those smaller things.
Yeah.
Yeah.
So they're in the Bering Sea for roughly how long?
Ooh, you're testing my specific knowledge here. A couple of years. They do poke into the North Pacific for sort of like the final stage of their rearing before coming back. In general, I mean, the ocean life of salmon is an interesting one, because they have done, there have been extensive ocean surveys that catch fish and try and find out, like, using genetic tools, they can identify their rivers of origin, or regions of origin anyway. But we don't know what we don't know, like, where they haven't done these transects, or just because they haven't found fish in a certain area, it doesn't mean they're not there.
Yeah.
And so you'll often hear, studies of like, oh, Chinook are rearing in this area, or this is the migration pattern they have. But we just have to bear in mind, as we do with all science, like, if we didn't go there and sample, we can't say they're not there. A positive hit of like a salmon is here, that tells you where it is, but it doesn't tell you where they're not, right? And so when you're talking about like the vast Pacific Ocean, we really have to keep in mind like the limits of our knowledge about where they go and when they go there.
I think that piece is such an interesting point to bring up, because modeling data, like how do you model, a fish that migrates how many kilometers roughly, do you know? Like, if it was
total?
in the Bering Sea, like, what is our idea of a migrational pattern?
Like how like distance wise, how far would they go?
Is it going down the coast? Is it staying in like a main area?
Yeah, well, that's, I think, where there's a lot of unknowns. Like, I'm sure there's many people who know more than I do about this, and I wouldn't want to kind of speculate too much, but there's a lot of different lines of evidence for the migration routes that salmon take and how long they spend in different areas. And Chinook in particular do all sorts of interesting things and can have very population specific migration patterns.
Oh, cool.
So in particular down, if we go back down to the Broughton, where I spent a bunch of time, that's kind of a nursery area for Chinook. So they'll spend, a year or a couple of years even there. They won't actually go straight to the open ocean like species like pink do. So there's all sorts of different migration patterns, and I think we have like just a sliver of an understanding of what they're doing. Yeah.
Okay. Yeah. It's so fascinating. Sorry to pick your brain so much
you're stretching my knowledge here.
Your knowledge on it.
But that's good.
I think
as a scientist, you learn when to say like, I'm not really sure.
Yeah.
Otherwise, you get in trouble.
Absolutely. Yeah. But it also, I think that uncertainty is because it's such a complex story. Mm-hmm. It's an ecological story that is touching, like you even mentioned with the Yukon River. You have Alaska, you have the Yukon.
Yeah.
Like there's so many moving pieces and so many stressors that are in that story, and you have this life cycle of juveniles making it their way to the ocean, then coming back.
Yeah.
And yeah, like how with all of that in mind, I guess what are some of the high level things that you think people are missing when it comes to the salmon collapse story? What do you think is really important that people are aware of or think about or try and support?
Yeah. Well, salmon have collapsed in a lot of rivers up and down the coast. And the causes are, multi-factored and complex, as you've been getting at. But if we think about Yukon Chinook in particular, I think one of the things that I hear more and more about as a scientist, but maybe is not so well known by the public, is that these fish have undergone a dramatic, what we call a demographic shift over the last number of decades. So they've gotten smaller, and not only are they smaller, but they're coming back at earlier ages. So they're younger, but they're smaller at each age class, and the females are producing fewer eggs. And so together, those factors mean that every Chinook that returns to spawn is producing fewer babies than they used to. And that not only, can cause a population decline on its own, but it means that they're less able to bounce back from other stressors. They're less resilient, right? Like they have a lower population growth rate. And so if there's any other stressor, that stressor can be removed and they just won't bounce back as quickly as they used to. And so I think that's an underlying issue that kind of impacts everything else because they just can't come back like they used to.
Yeah. Mm-hmm. Can't come back. And like what role do you see them playing in the landscape and the ecosystems, like all the different moving pieces that are deeply dependent on this species?
Mm-hmm. Yeah, they're an important species ecologically. Like they connect marine ecosystems to terrestrial ecosystems. They bring important marine nutrients back upstream. Rivers are continually washing things downstream and the salmon bring them back.
Yeah.
And so I think especially in interior ecosystems like we're in here, we're way upstream, we're in more of a continental climate, and it can be maybe less rich than a coastal ecosystem. And so the salmon bringing those nutrients, marine nutrients up the river are like critically important to these ecosystems. If you think about a bear, I remember actually when I hiked the Chilkoot Trail a number of years ago, the old Gold Rush Trail that goes up from Skagway up to Carcross. And I remember they told us like, okay, you're allowed to eat berries on the Alaskan side, but once you cross over the pass, you're not allowed to eat berries. You need to leave them for the bears because the bears on this side don't have salmon and they don't have fish in the same way. And so I think that's a good analogy for like these ecosystems overall. Like once you get into the more continental climates and ecosystems, they don't have that coastal influence as well, but the salmon bring it. And so they're so important for the ecosystems, for the bears, for the wolves. Not the wolves so much here. Coastal wolves will eat fish, but then of course there's the cultural component, right? And this is something that I was really naively surprised by when I moved to the Yukon. I didn't think of it as a salmon place, but the First Nations here consider themselves salmon people. Like the salmon are so important to them. And so that, like whenever I hear the local nations talk about the loss that they feel with Chinook and chum disappearing from the landscape, it just breaks my heart, and it makes like, I got nothing, like that connection and that sense of loss is so profound. And so I think that's what the loss of salmon means, both culturally and to the ecosystems.
Yeah, extremely well said. It's like even the short time that I've been up here, just that idea of people, place, and identity, I've definitely picked up on the identity of salmon in the north, and having the privilege of spending some time with some elders that have shared their story of fish camp and their childhood shaped by salmon. It really is such a deep, profound connection to the landscape, and really well said. I do want to circle back to that question that you tried to steer this conversation away. Just kidding. But land-based experience, I think, plays such a pivotal role in research, but also like personal development. And I can imagine being 19 in Broughton Archipelago, having that experience that might have felt, so deeply moving and inspiring. And like, can you explain in your own words, like, what does land-based experience mean to you?
Yeah, it's an interesting one because I actually spend a lot of my time now working on data, and as a modeler, I interact with a lot of people who might never have been to the places where the data was collected that they're working on, or don't have that concept of the work that went into the numbers they're reporting. So I can see both sides. Like I do think it's important. For me, it's inspiring. Like it's really where I draw my energy and my motivation to do the work I'm doing. But I also think it's important to ground, get that real world picture of like, oh yeah, these aren't just numbers. Like this work is important, and it's also imperfect, right? Like it's easy to put maybe more weight into the data than is warranted. But when you see, how dynamic the environment is that these numbers are being collected in, like a salmon sonar, maybe you actually look at the sonar video that someone's reviewing and you go, holy cow, like that seems pretty uncertain, and that's one of the more reliable ways to count salmon. So you realize, I think, like the imperfection in our numbers and our reporting, and that's important to keep you grounded and keep you aware of the uncertainties,
Yeah. But so I think it goes into the research aspect as well, but even I wonder if there's like a missing piece. It's something that I've been exploring a lot around rites of passages. And I find experiential learning, land-based experience, has such a ripple, it seems, in so many practitioners and researchers that I've met along the way. And I think it ties together that some of these ecological systems are so complex, and there's so much social and environmental pieces that intersect with it. And I, like, even speaking from my own journey, that's what happened for me. And you just start to contend with things a little bit differently, and you start to see that science isn't as clean, I think, as I once thought.
Yeah, you're right. And I think that's, like, again, going back to my initial experience in the Broughton, being in that environment, you see how dynamic it is, and how, going out and sampling day after day, you realize, what you find one day might be different the next day. Like it's such a dynamic environment, and that, like, being there for an extended period of time and going out every day is a really good way to get a better sense of what's really going on. And on the flip side, there were some parallel sampling programs happening at the time run by the government, where they'd go out and sample, 2 or 3 times a year and say, this is what we found.
Yeah.
And you can picture like the numbers that we're recording going up and down every day. And then, you pick like 2 points there and say, that's what's going on.
Yeah.
So you really do need that more continuous perspective on what's happening. And I think, to take that even further, what we're seeing these days is an increasing recognition of the knowledge that local people and Indigenous people hold, because they are out there on the land, and have been every day for generations. Like, that knowledge is passed down. So now just think about, as a scientist, you're going out a few times a summer maybe, or doing a survey once a year and looking at a time series of data. And then think about the depth of knowledge that's held by someone who every day is in that environment watching what's going on. And so I think you do have to realize your blind spots as a scientist, and the data we collect, it's one perspective on what might be happening, but it can be missing a whole lot, and it's really easy to get it wrong.
Yeah. And it's consequential to get it wrong.
Yeah, I mean, it can be consequential if you're overly confident, right? And I think that's what we see often is researchers saying, oh, well, my result was statistically significant, or, the flip side, actually, you see more often, it wasn't statistically significant, so there is no effect. And again, returning to the aquaculture example, it's so easy not to find an effect if you sample at the wrong time, or you don't sample frequently enough, or whatever it is, right? But you can't take that as evidence that there's no effect. Like, a lack of evidence of an effect is not evidence of a lack of effect.
Yeah.
To use an old adage that is mind warping a little bit, right? Like, we need to really realize that we have an imperfect perception of what's going on.
Yeah.
And so, we don't want to overinterpret our results.
Yeah. Do you feel a connection to the Broughtons? And I know you've done some research in the Arctic that has given you that peripheral overview of seeing the shortcomings and some of the gaps, and more of a holistic.
Yeah, for sure, in different ways though. Like, it's been interesting because I think in the Broughton, when I was working there, I wasn't working so closely with local people as folks are now, but there was, like I said, these parallel government programs that weren't doing as intensive of sampling. And so that in that case, it was like, okay, you've got these two sampling programs that are finding different results. How can that be? Like, isn't science supposed to tell us the answer? Like, what's going on here? Oh, like, science is imperfect. And then I think later on in my career, when I started doing more work up north, I had the privilege to work with a lab group at the University of Calgary who was doing a lot of wildlife health research in the far north, like Uluwaktuk and Kwäch'än,
Oh, wow.
sort of Victoria Island area. And they worked very closely with hunter and trapper organizations and people, Indigenous communities out on the land. And that was really interesting, because then you realize how science really doesn't know what's going on, because when you start to go that far north, there's so few research programs, so little sampling monitoring happening. But, the Inuit are relying pretty heavily on being out on the land every day. Like, they know what's going on.
Yeah.
And so you really see that that kind of difference in knowledge. And that group was working really closely with local communities to understand wildlife health. And I think that was a really valuable lesson too, in that, we can do a caribou survey once a year, but totally miss the point, because the caribou aren't where we thought they were. They're over there. But we don't know that because we only go once a year. And the people out on the land are going, well, what are you doing sampling over there? They're over here. So yeah, I think, those two cases really emphasize to me that even though we try and take this scientific method, this standardized, repeatable approach, and apply it to ecosystems, in many ways it's really ill-suited to studying natural systems, because they're so dynamic that we just can't go and do it in the same place at the same time once a year and expect to know what's going on. Like, it just doesn't work that way.
Yeah, and I think it's important to be out on the landscape and see that, to know those shortcomings.
Mm-hmm.
And I think that it sounds like has been instrumental in your ability to see the holistic side of ecological systems and starting to piece in together some of that map that is so complicated and like a lifetime's worth. What advice would you give if there was a young, aspiring researcher or practitioner getting into the space, really wants to work on important social and ecological, systems and problems, like from your wealth of experience? What are some of the pieces of advice you'd give them?
Yeah, I think just kind of what we just talked about, like our knowledge is imperfect. Any type of knowledge is imperfect. So, science is the tool I use to try and understand the world, but it's no more valid than other ways of knowing. And the truth of what's going on is somewhere in the middle, but no one has a clear line of sight to that,
Well
right?
said.
And so we're all trying to use the tools we have at our disposal to get at it. And I think by recognizing that other ways of knowing, might also have insights to that we can all learn from, is both humbling. Like it makes you realize, okay, I don't have all the answers, but neither do they, right? You also have to, I think, take other types of knowledge and other things that you hear with a bit of skepticism, and not skepticism, maybe that's the wrong word, but think carefully about it, and not just, why would someone say something like that? Where does that story come from? What's going on underneath there that would cause them, that would make that so important that it's been passed down for generations? What can I learn from that?
Yeah.
And that's something that I think's been so cool for me, is realizing that a lot of these stories and legends that get passed down they're deeply meaningful, and they're rooted in some important lesson that I think we can all learn from.
Yeah.
We just maybe have not figured it out yet. Even things that sound totally outlandish, you're like, oh, that's a crazy creation story. You're like, well, no, what is it? What is going on there? Why is that being told, and what can I learn from it?
Yeah.
Yeah.
Extremely, extremely well said. I really enjoyed a couple of conversations ago. You and I were talking about this idea of, holding space for the day that salmon comes back. And, multiple ways of knowing and traditional values speaking to that relationship to the land and being, connected to it and multi-generational. It seems like you're touching on something that's in line with, having foresight, having humility, having an openness to, one, having that relationship with these landscapes, but two, drawing from multiple perspectives, multiple angles, multiple ways of holding space. I don't know if that was coherent, but was that coherent?
I think so. Yeah, I gotcha. Yeah, I think with the saving a seat thing, I mean, that comes back to, we might not understand exactly why salmon have declined. We have some ideas. We might not understand exactly what they need to come back, but we need to save that space for them and do what we can, right? And so, again, coming back to the Yukon River here and the Yukon River salmon story, they probably, what we're seeing now probably isn't just the result of one impact on the landscape here, but it doesn't mean that we don't have to protect their spawning habitats and make sure that they have a place to come when they do come back.
Yeah. Yeah. One final question around kind of what's a practice or approach that helps you connect with the natural world that you think would be insightful or valuable to others?
We were coming full circle here back to the spot and taking that time, right?
Yeah.
To get away. And for me, it's not just getting away on a lunchtime run and coming here for a breath for a minute or two, but it's making sure to take chunks of time and get out on the land and get away from my computer screen and connect, spend time with my kids out in the wilderness. And so we do that here in the Yukon, trying to get out on river trips in the summer and take that quality kind of longer chunk of time where we can disconnect. I think we're so connected these days, and it's hard to get away from the messages and the emails and dealing with the priorities on our to-do list, but
Yeah.
to take that like longer bit of time, a couple weeks if you can afford it, and just disconnect for a little bit,
Yeah.
refocus. Yeah.
I said it was the last question, but I do.
Okay, picking up on something there.
When
Yeah.
you talk about doing these trips with
Yeah.
your kids, like, what have you seen growth-wise, and like how are your children receiving these gifts that you're giving?
Yeah, I mean, they love being outside. We're so fortunate to live in a place where you can kick them out the back door and they have woods to go play in and forts to build. It's funny, they go to school just not far from here, and they build forts. That's just what they spend their time doing, is building forts in the woods,
So
and,
cool.
and when we go visit my relatives down south, their kids are so good at basketball and soccer and hockey, and they're like, well, what do you guys do at recess? And my kids are like, we build forts,
Yeah.
But it's such a privilege, right, to be able to go outside and have these spaces. And I think they appreciate that. They appreciate the time too. Like, I think as a parent, those trips are an opportunity for me to focus on them more and not be worried about work or having to go grocery shopping or whatever it is, right? It's just like focus on talking to them, teaching them, spending time with them,
Yeah.
and playing.
Totally.
Yeah.
It's spending time, but it's such intentional time. And
Yeah.
I think it's so instrumental in, I imagine, the environmentalists that they'll be one day
Well, we'll see.
following
Yeah.
their parents'
No pressure.
footsteps. No pressure.
Yeah.
I guess, promise, this is the last one, but if you were to give pieces of advice, I know many of my peers that have just had children, they're trying to find ways to kind of weave in the natural world into their habits and the activities that they participate with their children.
Mm-hmm.
Like what would you say to a family that's never done a canoe trip and is looking to have this experience together? Like,
Yeah.
Yeah.
I just love how kids are so interested in like everything, right? And so just pausing and taking time to, almost like the little research scientist in me, like be like, oh, look at that squirrel's doing this. Like, why do you think they're doing that? And kids just will pick up on that, and the things that they come up with or think about, the ideas that they have. And like, nature is just full of those little questions,
Yeah.
right? And kids love that. And so just taking time to look at what's around you and wonder with them at the natural world is so fun. And anyone can do it. You don't even need to be, a million miles from anywhere in the Yukon.
Yeah, it's so true.
You can do it in a park in the city and
Yeah.
just like look around you and see what's there. And kids' minds are just so incredible that way.
Yeah. Yeah. It's, I think, such a gift that you're giving them, but also such a gift that they're giving you. And I imagine that curiosity just feeds that deep researcher.
Yeah, well, it's funny because like nowadays, you can wonder for a few days or a week, and then you can look it up on Google.
It's so true.
So we do some of that too. Like,
Yeah.
oh, that's cool. Like, that's a cool behavior. Why are they doing that? I don't know. Maybe Google can tell us. So it's not all about figuring it out yourself.
Yeah. Steph, I have so enjoyed this conversation. My feet are
Yeah.
properly numb.
Okay.
So,
Yeah.
thank
it's,
you. Is there anything that you think that we missed that you would like to say?
I don't think so. It's been really, really nice to talk to you, and I'm glad that we froze our butts off here just to enjoy this view.
Yeah.
It's my moment today. So thanks.
Thank you.